Hi, myself Gautam Kumar T. I'm from Venkateshwar College of Engineering, Bangalore. Today I'm going to explain about file system and input and output. First, let us look into the contents. Today I'm going to explain about Linux and Linux process file system, that is file system, and input and output, that is block devices, character devices, and network devices. First, let us look into the Linux or introduction to Linux. Linux is a free OS based Unix standards like Linux plus Unix is equal to Linux. Linux is an open source software, that is, source code is made available free on the internet. Linux was first developed as a small self-contained kernel in 1991 by Lucius Tower. Major design goal of Linux project Unix capability. In earlier days, Linux development resolved a larger around the central OS kernel. Kernel Kernel is divided into managing all systems and resources interacting directly with operating or computer hardware. Next, let us look into the Linux processor file system. That is file system. The Pro file system does not store data. Rather, it contains are computerized and determined according to the user's files input and output requests. The f- the Pro file systems The processor file systems must implement two things: a directory structure and a file contents within it. Process must define a unique and precise ION number for each directory and associated with the files. Use an ION number to identify what operation is required when a user try to read a particular file or perform a lookup particular directory order. Next, when a when data are read from the files, Pro will collect the proportions of information, format into textual format, and place it in the request process reading buffer. The kernel can allow new or pro-idle maps dynamic maintaining a bitmap of allocated ion numbers. The kernel also maintains a tree data structure of registered global profile entities. Each enti- entry contains files ID number, files name, access permission, specific function, and user to generalize the file's contents. Drives can register the and deregister entities in these trees at a time, and a special section for trees is reserved for kernel variables. To use to the user, Linux file system appears as a hierarchical directory structure obeying Unix symmetrics. Initially, the kernel hides the implementation details and manages the multiple differences file system via an abstract layers, that is the virtual file system VFS. The Linux virtual file system is designed around object oriented principles and is composed of two components: a set of defines that define the file object is allowed to look like the inode object, and the file object structures represent individual files. The file object represents an entire file system, a layer of software to manipulate those objects. Next, the Linux extract to FS file system. The extract of user mechanism similar to the BSD file fast file system FFS for the locating data blocks belonging to the specific files. The main difference between extend to files or and FF files concern their disk allocation policies. That is, in FFS, the disk is allotted to the file in blocks of 8 KB, with the block behind the subdivided into fragments of 1 KB to store small files or partial files block at the end of files. Extends to file does not use fragments. It performs its allocation in smaller units. The default block size on extents is 1 KB, although 2 KB and 4 KB blocks are also supported. Extends to file use allocation policies designed to place logical adjustments block of the file into physical adjustment blocks on disk so that it can submit an input output request for several disk blocks in a single operation. This is about Linux extends to file systems. Now let us look into the diagram of extends block allocation policies. In the first one, you can see the allocating scattered and free blocks, which means the spaces is free, it is allocated freely. Next it is like allocating continuous free blocks, where some blocks are free and other blocks are filled. As you can see, the darker blocks are used and the later objects are free. The dotted objects are block that is allocated and selected. And the arrow mark selects the bitmap search, and the light, lighter line of is bit boundary, and the darker line is bit boundary. Difference is bit and byte. Now let's look into the Linux process file system. The, the proc file system does not store data, rather it contains compute of determine allocating the user file input output request. Process must implement a direct structure and file containing within it. It must it must then define a unique and prestige enable number of for each directories and files it contains. It uses the inert number of identify just what the operation is required when the user tries to read the from a particular file annoyed or perform a lookup particular directory annoyed. When a data is read from one file, these files, the pro collects the appearance of information, formats into text formats, and places in the request processor of the reader's buffer. This was all about the file systems of Linux. Now let us move to the next one, that is input and output of Linux systems. These input and outputs are divided into three topics, that is blocked devices, character devices, and network devices, which three are interconnected in this Linux. Like we can see the uh, these topics from the below figure, that is file system which deals with file system or blocker devices, which deals with the part one. The next one is character devices, which is connected with the network devices drive, where three are interlinked. And to run a Linux system we need these three devices. Now let us move on to the brief of each topic, that is block devices, character devices, and network drives. block block drives devices. Block device allows a random access to completely independent fixed size block of data. For example, hard disk, floppy disk, CD-ROMs, and Blu-rays, and flash memories also. The blocked devices are typically used for storing file systems. Next one is character devices, character drives. Character drives or devices does not allow offer random access to the fixed block of character. For example, mic and keyboard, which cannot be blocked or which cannot be fixed. Example, character device includes mic and keyboards, network drives. User cannot directly transfer data to the network. Instead, they must communicate directly by operating a connection to the kernel network subway system. These network devices majorly used for used when there is connection of kernel network subsystems, where kernel is an intermediate between the devices or parts. Now let us look in detail. The first one, block devices. Block device allows the random access to complete independent fixed size block of data. For example, hard disk and floppy disk, CD-ROMs and Blu-ray disk. and flash memories. Block devices are typically used to store file systems. Block devices provide the main interface to all devices, disk devices in the system. A block represents the unit of which the kernel performs of input and output. When a block is read into the memory, it is stored in a buffer. The request manager is laid out of the software that manages the reading and the writing of buffer containing to and form of a blocked device drive. A specific list of requests is kept for each block device drives. This request is scheduled according to the CSCAN algorithms. Now let us look into the next one. That is character devices. A character device does not allow often random access to performance blocks of data, for example, mics and keyboards. Difference between block and character devices. Block devices are accessed randomly. Character devices are accessed serially, where you can choose the memory randomly in block devices, but in character it is in the order which is serially. The character devices drives must register a set of functions with implements a drive various file input and output operations. The kernel performs mostly no processes of a file read or write requests to character device. Kernel simplifies pass the request to the drives. The main expectations to this rule is specifically subset to the character device drive which implements the terminal devices. The kernel maintains a standard interface to this device drives. Aligned discipline is interface for the formal form of the terminal device. The most of common line sublines are TDL disciple, which glues the terminal data streaming onto the standard input output streaming of the user running process. This allows the process to communicate directly within the user's terminal. Thank you. This is all about today's presentation.